Now watch this question. This question is asked in GATE 2004 in IT paper. Back then, I think till 2007, CSE and IT used to have two different papers, computer science and IT. Later they combined it. So if you can find all the IT papers as well as CSE papers, I think you'll have lots of questions to solve. Okay, now watch it. In a virtual memory system, size of the virtual address is 32 bits. So they are saying that the virtual address size is 32 bits. So what is virtual memory system? So generally virtual memory system comes into picture whenever the size of a process is very much bigger than the size of the main memory, and when we are not able to load the entire process in the main memory, what we do is we load only part of it and we run it. That concept is called as virtual memory, right? And what is demand paging is, there is something related to demand paging too. Demand paging is whenever you start running a process, if you start the process with only one page in the main memory, and later if you load more pages, then that is called demand paging. Okay, I think I am confusing you. Okay, again, virtual memory is if your process size is very much higher than the size of the main memory, then we cannot load the entire process in the main memory, then we load only the part of the process which we can fit in the main memory, and we will run it, and whenever this part is over, we pull it back and take the other part, exactly like the overlaying, right? But then overlaying is done at the users is in the user's control, but then virtual memory is completely provided by operating system, and so therefore user is relieved out of that burden. Fine. Now what is demand paging is, in virtual memory concept, you could load many processes at the same time, or you could load only one process to start with, and later if you need more one page to start with, in virtual memory you could either go in two ways. See, for every process there will be some fixed number of frames allocated. Now you can fill all the frames which are allocated to your process with all the pages of the process or some of the pages of the process, or you can begin with one page and then later as the demand increases you can keep on loading the pages, right? If you start with only one page, or if you start with 0 pages and continuously keep on loading one by one, that is called demand paging. So virtual memory and demand paging are not independent, are not different, right? A virtual memory can have even virtual memory can have even this concept of demand paging. Okay, fine, let's do one thing. I'll keep this topic separate. I will not teach you along with this. Let's keep it separately and we shall do it separately. Okay, for now just understand that here the size of a process is, the virtual address is 32 bits. Therefore virtual address space or the logical address space is 2 power 32, right? And then the size of the physical address is 30, which means size of the main memory is 2 power 30. So the main memory address is less than the virtual memory address. So what can you say about this? Clearly, we need to go for virtual memory, and the page size is 4 KB. So what is page size? The size of the frame is equal to size of the page, which is 4 KB, and each of the page table entry is 32 bits. It is interesting. So now the page table size, entry size is also given. Generally, if they don't give you anything, we assume that it contains only the frame number, right? But here the page table entry size is also given, and then they are saying the main memory is byte addressable. So this is important, right? Why? Depending on the granularity of addressability, which means what is the smallest unit of the main memory which you are going to address, we are going to choose the number of bits in the addresses. Now whenever they say that it is byte addressable, they mean to say that the entire memory, if it is 32 bits is the virtual address space, then the virtual address, then the virtual address space is 2 power 32 bytes. In case if they say that it is word addressable, then okay, see what I mean to say is, since they are saying that it is byte addressable, and since they are saying that virtual address equal to 32 bits, right? Then what about virtual address space? Virtual address space is 2 power 32 into what is the smallest unit that is addressed in this system. They are saying that it is byte addressable, therefore I am going to write it as bytes. In case if they say that it is word addressable, then I will write it as 2 power 32 into words, and then I can convert words into bytes by using the information about how many bytes is each word, right? So this is why this is required. If it is byte addressable, then we are going to take the virtual address, and then the number of the address space will be 2 power 32 into the addressable units, and in this case it is bytes. Then which of the following is the maximum number of bits that can be used for storing the protection and other information in the page table. So in the page table, we are not just going to store frame number. Along with that, we are going to store many other information like protection and modified, all this, right? So they are saying along with this, how many maximum other bits can be used. So what the question is this: if you have the page table, right, and if this is the page table entry, this is the page table and this is the page table entry, and now it contains two parts. One is frame number and the other is extra bits, right? All these bits are protection bits and everything put together. Now they are saying that this entire entry put together is 32 bits, right? And they are asking how many bits is this remaining part other than the frame number. Now you are supposed to find it out. In order to do that, you are supposed to find out the frame number, right? Once you get the frame number, then you can subtract it from 32 and you can get the answer. So what are the fields which are relevant here? You need not worry about all the parts. They are saying that physical address is 30 bits, right? And page size equal to frame size equal to 4KB, and it is a byte addressable. Therefore, what is the number of bits used for page offset? The number of bits used for page offset equal to, since it is, you can write it as 2 power 12 bytes, isn't it? Page size, therefore it is 12 bits. So 12 bits are used as the page offset. If 12 bits are used as the page offset, then how many bits are used for frame number? Page offset or frame offset, both are same. Then how many bits are used for the frame number? Frame number is equal to physical address minus page offset. We have already seen it. Now what is this? It is 32 minus 12, right? So 32 minus 12, 30, right? Physical address is 30. 30 minus 12 is, I think, 18, right? So 18 bits are used for the page number, frame number. Therefore, in the page table entry, the frame number contains 18 bits. If it contains 18 bits, then how many are the remaining bits here? I think 14 bits, isn't it? So the answer is 14. This is how you can answer, right? So the other information is not really required. What we don't need anything about the virtual address space. In case if they would like to ask what is the page table size also, maybe we shall do it. Can you tell me what is the page table size? Page table size depends on number of pages into size of each page table entry, right? For that I have to find out the number of pages. Then how can I find out the number of pages? If virtual address is going to be 32, right? Then what about page number? Page number bits. Page number bits is equal to virtual address minus page offset, isn't it? So that equal to 32 minus 12, which is 20 bits. 20 bits are required to identify the page number. If 20 bits are required to identify the page number, then how many pages will be there? 2 power 20. So the total number of pages present is 2 power 20, and each page table entry size is 32 bits. Therefore, this is the total page table size. They didn't ask you this, but still, you could even, using the information, you could even calculate it. Understood this? So what is the specialty of this question? One thing is they are talking about virtual memory. Virtual memory means the size of the process is greater than size of the main memory. And second thing is they are saying that it is byte addressable. Byte addressable means whenever they are giving you some address bits, then in order to get the address space, you have to take 2 power those many bits multiplied with the bytes. If it is word addressable, take 2 power those many bits multiplied with words. Got it? Okay.